Hi and Assalamualaikum to everyone. Okay, so today I will first introduce the concept of volumetric analysis. Volumetric analysis is a quantitative analytical technique that is used to determine the concentration of an unknown solution. In simple words, it helps scientists find out how much of a certain substance is present in a solution. Okay, so to do this, volumetric analysis involves measuring the volume of a solution with a known solution, which is called a standard solution, that is needed to react completely with the unknown solution. Okay, as shown in this diagram, we start with an unknown solution, also known as the analyte. The solution contains the substance that we want to measure. Then a standard solution, also known as a titrant, is slowly added until a complete reaction occurs. At the end point, where the reaction is complete, we can use the volume of a titrant added to calculate the concentration of the unknown solution. For example, if we know the concentration and volume of the standard solution, we can determine the amount of substance in the unknown solution using calculations based on the chemical equations. Okay, now let's move on to the next slide. Okay, now moving on to the principle of volumetric analysis. Volumetric analysis usually involves a reaction between two solutions, the analyte, which has an unknown concentration, and the titrant, which has a known concentration. The most common technique used in volumetric analysis is titration. During titration, the titrant is placed in burette and slowly added into the analyte in a conical flask. The purpose of adding the titrant slowly is to make sure that the reaction can be controlled accurately. An indicator is usually added into the flask to help identify the endpoint. Okay, the endpoint is the point where a visible color change occurs, showing that the reaction that has been completed. For example, it will usually show as the pale pink color. Okay, this diagram shows the progression of titration. Before titration begins, the solution has its original color. As the titrant is added, the color starts to change when it approaches the endpoint. Once the endpoint is reached, a permanent color change can be observed. As what I told earlier, the color of pale pink will always occur when the reaction are occurred. Okay, for our experiment, we apply this principle using an acid-base titration to determine the concentration of acetic acid in a vinegar. The reaction occurs between acetic acid from vinegar and sodium hydroxide solution, where they react in a 1:1 ratio to produce sodium acetate and water. The volume of sodium hydroxide required to completely neutralize the acetic acid allows us to calculate the concentration of acetic acid in the vinegar sample. Okay, let's move on to the next page. Okay, so for this page, we will talk about why volumetric analysis is very important in our daily life. Okay, so we'll talk about the applications of volumetric analysis. Okay, firstly, it is involved in food industry. It determines the acidity levels in products such as vinegar, fruit juices, and dairy products. It ensures product quality and safety. Secondly, pharmaceutical industry. It determines the amount of active ingredients in medicines and also ensures correct dosage. Okay, in addition, we will talk about environmental monitoring. It measures pollutants or chemical components in water samples, so it will be safe when we drink it. Okay, lastly, we will talk about the research and quality control used to verify purity and concentration of chemical substance. Okay, now let's move on to the next slide.
I will talk about vinegar, acetic acid, and the importance of determining the concentration of acetic acid. First, vinegar is a sour liquid produced through the double fermentation of sugary substrate. In this process, sugar is first converted into alcohol, and then the alcohol is converted into acetic acid. This acetic acid is what gives vinegar its sour taste, strong smell, and high acidity. Vinegar is commonly used as a food preservative, condiment, and also for household purposes such as cleaning and as a mild antiseptic. Next, acetic acid, also known as ethanoic acid, is the main component of vinegar. It is responsible for the sour taste and smell of vinegar. Usually, vinegar contains about 4 to 6% acetic acid dissolved in water. Acetic acid is also widely used in industries such as food production, plastic, dyes, pharmaceuticals, and textile. Finally, determining the concentration of acetic acid is important. It ensures the quality of vinegar by maintaining consistent acidity, flavor, and preservative properties. It is also important for quality control during production to make sure the product meets food and industry standards and to detect any variation in the process. In addition, it is important for safety because different concentrations have different level of corrosiveness. So knowing the exact concentration helps ensure proper handling and use. In conclusion, vinegar and acetic acid are important in both daily life and industrial application, and measuring its concentration is essential for quality, safety, and consistency. Okay, next I will explain the principle of acid-base titration used to determine the concentration of acetic acid in vinegar. Acid-base titration is based on a neutralization reaction between an acid and a base. In this experiment, acetic acid, which is a weak acid, reacts with sodium hydroxide, a strong base. The standard sodium hydroxide solution with a known concentration is gradually added to the acetic acid solution of unknown concentration until the equivalence point is reached, where both substances completely react in a 1:1 stoichiometric ratio. The reaction is represented by equation. Acetic acid reacts with sodium hydroxide to produce sodium acetate and water. To detect the change during titration, phenolphthalein is used as the indicator. It is colorless in acidic solution and turns pale pink in slightly alkene condition. The endpoint is reached when all the acetic acid has fully reacted with sodium hydroxide. This is shown by a permanent pale pink color, indicating that the neutralization is complete. From this titration process, we are able to determine the concentration of acetic acid in the solution.
For methodology, to determine the concentration of acetic acid in vinegar, an acid-base titration was performed using a standard sodium hydroxide solution. First, the burette was rinsed and filled with 0.100 molar sodium hydroxide solution. The initial volume was then recorded. Next, 25 ml of vinegar was measured again using a pipette and transferred into a conical flask. 2 to 3 drops of phenolphthalein indicator were added to the vinegar sample. The solution remained colorless because it was acidic. The sodium hydroxide solution was then added slowly from the burette into the conical flask while continuously swirling the flask. As the titration approached the endpoint, the sodium hydroxide was added drop by drop. The endpoint was reached when a faint pink color appeared and remained visible for about 30 minutes. This color change indicated that all the acetic acid had reacted with sodium hydroxide. The final burette reading was then recorded. The volume of hydroxide used was calculated. The titration was repeated 3 times to obtain more accurate and reliable results. The average tide volume was then used to calculate the concentration of acetic acid in the vinegar sample.
As for the result, all you determine the percent of acetic acid in vinegar sample. For the first, we had to search the equation of HCl and NaOH. The way we will produce HCl and sodium chloride and also water. From this equation, we can find the mole of HCl because the information that we got from our experiment is HCl concentration is 0.1, volume of HCl is 20 ml, and 1 mass of acetic acid is 60 gram per mole. And also the result is we got an average mole of HCl is 14.25 and average volume of NaOH is 22.45. From the information, we can have a mole of HCl. To find the mole of HCl, we use the formula of mole. It is mole equal to mv over 1000. So for the information, we just fill in to formula is 0.1 divided with 20 over 1000, and you will got 0.002 mole. Okay, but we need to find, we need to determine the MV. This is the HCl. When we search for HCl, because we only have information for HCl, so from the equations, we find the ratio of HCl and NaOH is the same. It is 1 over 1. So NaOH also the same mole like HCl. From the answer that we got, we can have a molarity of NaOH. To find molarity of NaOH, we use M over equal N over V. N is for mole, N is for mole, V is for volume, M is for molarity. Okay, mole, we insert the answer to N 0.002 over 0.01425 with 2. And volume, where can I get the volume? You can get the volume from the average mole of HCl because the ratio of NaOH and also HCl is the same. That's why we use the HCl average volume. Can get the answer is 0.1404 mole. The third step is we need to find the mole of acetic acid. Acetic acid, as we know, acetic acid has CH3COH. Now, to find the mole of acetic acid, we need to make an equation because it reacts with NaOH. So CH3COH plus NaOH will produce CH3CO Na plus water. From this, you can get, we need to find the mole. Like, first step, so 0.1404, 22.45 over 1000. You will got 0.003 mole. Like the previous one, step 1, the equation is, this is the balance equation. So you just need the first one before you produce the product. It shows that acetic acid and NaOH has a ratio 1 over 1. So this mole of NaOH and acetic acid also have a 0.03 mole. Step 4, we need to search the mass of acetic acid. Formula of mass of acetic acid is a mass equal to mole and molar mass. The molar mass of acetic acid is 16. So from the information and also the formula, we just insert the information. So the mole is 0.003 and 16 we get 0.18 gram. First, the terminator of original vinegar was added to 100 ml of water. Next, only 20 ml of distilled solution was transferred to conical flask for titrations. Since 20 ml is 1/5 of the total metal contains the acetic acid, only present 2 ml of original vinegar. The information, we can use it. Acetic acid and 100 over 2. So you will got 9.46 gram. This is a weight of acetic. The last part, the percentage of weight per volume. To determine the formula of weight of per volume, percentage is weight over volume. So in this formula, you can search the information. 9.46 per 100 ml. And you will got this. But usually, commercial vinegar has a 4 to 6% of vinegar. But from our result, we got 9.46%. So it's much higher than its expected.
Next, application. The determination of acetic acid concentration in vinegar has very important application in everyday life and industry. In the food industry, manufacturers use acid distillation to ensure that vinegar products contains the correct amount of acetic acid as stated on the label. This helps maintain product quality and consistency. The next one is volumetric analysis.
quality control laboratories to monitor the production process and ensure that products meet regulatory standards. Accurate measurements are essential because variation in acetic acid concentration can affect the taste, preservation properties, and overall quality of vinegar. The last one is food safety authorities may use this method to verify that commercial vinegar products comply with national food regulations.